Hello, in this video we're going to be looking at maximizing worker utility subject to a hedonic wage function, using mathematics to demonstrate Adam Smith's important insight. In The Wealth of Nations, Adam Smith writes about wage differences or compensating differentials across occupations. Quote, "First, the wages of labor vary with the ease or hardship, the cleanliness or dirtiness, the honorableness or dishonorableness of the employment. The trade of a butcher is a brutal and odious business, but it is in most places more profitable than the greater part of common trades. The most detestable of all employments, that of public executioner, is, in proportion to the quantity of work done, better paid than any common trade whatever." So here we have a worker's utility function. Utility is a function of the worker's wage and riskiness of the job. So W is the wage and R is going to represent job risk. Note here, as R increases, as job risk increases, utility falls, all else equal. R in this case is a bad economic good. We could show that by just taking the partial derivative of the utility function with respect to risk, and we get back this result. And the key thing about this result is that it is negative or less than zero. So as risk increases, the worker's utility falls, all else being equal. So our question here is to solve for the utility maximizing values of W and R subject to the market's hedonic wage function given by the wage equals 30 plus R, the risk level. The hedonic wage function gives a relationship between the market wage paid to workers and job characteristics. In this case, the job characteristic that we're measuring is riskiness of the job. We see with this hedonic wage function, workers earn an additional $1 for each unit increase in job risk. So once again, we're going to maximize utility subject to the constraint here. I'm going to do the substitution method where I have W. I'm going to replace W with 30 plus R. So now in the utility function we have 30 plus R raised to the power of 0.6, all multiplied by the rest of the utility function. We're going to take the derivative of this utility function with respect to R, and because we're maximizing, we're going to set that result equal to 0. And we get this mess right here. So what did I do? I start with this exponent over here, this 0.6, and that comes down in front. Then I subtract 1 from that exponent to leave us with minus 0.4. Then I look in parentheses here and I take the derivative of 30 plus R with respect to R, and that's just 1, which I'm showing in parentheses down here. That is all going to be multiplied by this remaining term here, this 100 minus R, all raised to the 0.4 power. And then I'm going to take the derivative this time of the 100 minus R raised to the 0.4. So this 0.4 comes down in front, right here. Then I subtract 1 from that 0.4. That's where this minus 0.6 is coming from. And then I'm looking in parentheses here and I'm taking the derivative of 100 minus R, which is just going to be minus 1. And so that's where this minus 1 is coming from. This all equals 0. We're maximizing once again. So moving some things around here, moving this chunk of terms over here to the right hand side, we lose that minus sign. We're left with this. Following the rules of exponents, I'll move some things down into the denominator. So anything with a negative exponent, I'll move that down into the denominator. And now we're going to just, cross multiply this 100 minus R raised to the 0.6 power. I'm going to multiply that through. Likewise, this 30 plus R raised to the 0.4 power, I'm going to just multiply that through. And you're left with this nicer looking result. Okay, moving on to the next page, rewriting that last step. Now simplifying here and simplifying once more. 60 minus 12 is 48, and adding up the R terms, we just get R. So the utility maximizing risk level in this example here is 48. If the worker is taking on a risk level of 48, according to the hedonic wage function, the worker would be paid $78. The worker's utility at these levels, just evaluating the utility function where W is 78 and R is 48, gives a worker a utility of a little over 66 units. We can look at this graphically. Here is our hedonic wage function, the W equals 30 plus R, vertical intercept of 30, slope of just 1. And then this is going to be the worker's indifference curve. Okay, it is upward sloping because job risk is bad. The worker needs to be compensated with higher wages to take on increased risk. So we're trying to find the tangency between the indifference curve, trying to get on the highest indifference curve possible. That is just tangent to the hedonic wage function, and that occurs at a wage of 78 and a risk level of 48. Okay, that's it.